and to type so you can kind of see it and be like, oh, okay, that's this kind of question. Really, in the textbook or anything else, they will just talk about regressions, okay, just regressions in general. So, but these ones are very unique. So profit type of questions, profit, revenue, income, anything like that fits this category right here on page 53. Okay, and how is this different? You need to create a table with the info given. Some of the keywords for this type is when you see profit, revenue, items sold, you're in this category, you're in this camp. When you're in this category, you want to make 3 entries, right? The cost or price per item, how many items are sold, items sold or rented, whatever, right? And last but not least, this column right here, which is your profit or your revenue column, which essentially asks us to take the cost per item, multiply it by the items that we're selling, okay? This last one right here is always what goes into L2, okay? That's always going to be our Y variable, this one right here. L1 is going to be one of these two here. And how would you know? The question will say, the question might say, make a quadratic equation that writes the profit in terms of the cost per item, let's say. Right? If it says profit and price per item, if you want to relate those two, then this is going to be your L1. If it says make an equation that relates the profit as a function of items sold, then guess what? This is going to be your L1, and that's going to be your L2, okay? What you never ever want to do, listen carefully, is make this L1 and this L2. Then you're going to get a linear equation. It's not going to be a quadratic equation, okay? So this one is always L2, and L1 may be one of these two. You just have to watch out and read carefully. Enter cost or items into L1, profit into L2. Note what goes into L1 depends on the wording of the question. Here it is. Does it ask for relating the cost and profit, or does it items and profit, right? So if it's cost and profit, obviously the cost goes into L1, the profit goes into L2. If it's items and the profit, it goes L1 and L2. And then you perform your regression using quadratic regression. Make sure the resulting equation does not have A is equal to 0. That would be a linear. Okay? That's an important note to make. If you do the regression and you get A is equal to 0, it's not a quadratic. Okay? Since L1 and L2 are being used, turn on plot 1. Okay? Obviously, all the regressions, we turn on plot 1. And we use Zoom 9 to help us see the graph. However, you're not sleeping, right? You're paying attention? Students always think Zoom 9 does it. That's it. No. You have to adjust your window until you see the entire parabola into quadrant 1. Okay? That's important. Okay. Generally, questions of this type will have scenarios where they're asking you, how can you maximize your profit? How can you maximize the money that you make as a company? This means that you will need to find the vertex. So if you want the profit to be maximized, you need to find the vertex essentially. That's most of the time what these questions are all about. Break-even situations will happen at the x-intercepts where you don't make any money. So I just like these two graphs here side by side. Both of these will have the profit in dollars on the y-axis. Okay. Both of them will have that. However, let's make this first one where you have the cost per item. You're comparing the cost per item and the profit. Okay. And let's see if you understand this part. I think this is basic finance, basic economics here. If you price something 0, you're not going to make any money. As you start increasing the price of the item, right, your profits are going to go up. They're going to go up, right? But there's a breaking point. There's a point where if you charge a certain amount, you will maximize how much you make as a company. But then if you start charging too much, what happens to your profit? It goes down. Why would that be? Too expensive. People stop buying, right? Exactly. So, and then that's why this is a quadratic. Okay. So that's what's happening, and we're always interested in this sweet spot here. Okay. So this would be the cost that you should charge per item, and you would obviously the y variable would be maximum profit. Similarly, you can compare profit and the items sold. By the way, let's go back to this one. The number of items sold is in here, but we don't see it, okay? But the items sold is what affects your profit. You don't see it. Okay? Here, you would compare profit and items, and so the vertex in this scenario would be the items that you would be expected to sell to maximize the profit. So that's all. Both of these, okay, both of these graphs, if you were to graph them, would have the exact same maximum profit. Okay, this number, regardless of which equation you made, whether you compared profit and items or profit and costs, both of them you would find out, oh, it's $1 million here, it's $1 million there. It wouldn't matter which one you chose. They would result in the maximum profit that is exactly the same. Okay? This is just so you understand what's happening in the background. So let's do our first example. These are actually not too bad if you're just careful. You just have to be careful when you read the question, what's happening? Is something going up or down? So let's go to 54. And I know these questions are a bit cheesy and the numbers are not realistic. We don't pay $1 for a movie anymore, okay? Those were the good old days. Are there still like $2 Tuesdays? That's still happening? Okay, so maybe this is more realistic than what I thought. A movie theater charges $1.80 per ticket. At this price, it sells approximately 400 tickets per day. Okay, so that's like our starting point. At this price, we sell 400. This is where it turns. The theater manager has observed that for every 10-cent increase in ticket price, 40 fewer tickets are sold. Which kind of makes sense, right? If you charge more, you're going to sell less, a few less. But let's see if we can figure out the sweet spot here. So you create your table. I'm giving you this table in this case. Usually I go cost per ticket. Okay, per tickets. And then this would be number of tickets. Okay, cost per ticket, number of tickets. This would be your profit, right? Profit would be taking the cost per ticket and multiplying it by the number of tickets in this particular case. Just so you know, it doesn't matter if you're on a test and you start with the number of tickets and you make this the cost per ticket, it doesn't matter. You just have to know which one is which. So, at $1.80 per ticket, we're selling 400 tickets. Okay? Which means that the profit under these circumstances would simply be $1.80 times 400, and we'll get that in a bit. We'll fill in the table first. So what happens to the price in this scenario? It talks about an increase for every increase, correct, of 10 cents. So this would be $1.90. So if you increase this by 10 cents, what happens to the number of tickets? It drops by 40. And that's usually what happens. It's an inverse relationship. Okay? So at $1.90, you're selling 360. So this would be $1.90 times 360 equals. And why are we doing 3 rows? Because we need 3 points. Okay, you could do more if you want. So let's do this one more time. So you're saying, hey, if I do another 10-cent increase as the manager, now I'm charging $2, okay, per ticket. What happens to the number of sales one more time? It will drop another 40. Because it says for every increase you drop 40. So now you're at 320. So this will be $2 times 320. And there you have it. Let's fill in this part. Maybe you just copy this because I'm fairly confident you know how to multiply numbers. Okay. This times this is 640. So this is your table. That's usually worth 1 mark. And determine the equation relating what? Relating the ticket price and the profit. So we knew already that this last one always goes into L2. There's no question about that. So this is L2. And ticket price goes into L1. So which one of these two are we going to pick? We're going to pick the cost per ticket, right? So this is our L1. Okay. So we go stat, calculate, quadratic regression. And let's go ahead and enter this. And make sure you don't put this column into L2. Very common mistake, common error. You go right to your profit. There we go. And I'm going to clear what's in my Y1. I'm going to turn on plot 1. And here's where I want you to pay attention. This is where zoom 9 is kind of like, it could be a problem for some of you because you're going to think it's a straight line. But it's not, because we know it's a quadratic. There's a quadratic relation between the two. If I go zoom and then press zoom 9, right? If I select zoom 9, watch what's going to happen. That kind of looks like a straight line, but it is not. Okay? So what you're going to do from here is, what am I always telling you to do after doing zoom 9? Window, okay? You should all do this. X min, I'm going to turn that into something negative. I think -1 will do for now. I go to my Y min, and look at how Y max it turned it into like 730. So there I will go -5. Okay, so my X min and my Y min, I go negative. Hit graph it again. I see a little bit more. Let's graph it to chase the curve afterwards. But you see these 3 points? These are the 3 that you found. That's just 3. There's way more. So let's do a regression here. Stat, calc. I already did this earlier, right? So I'm just going to go and find it on my main screen. There we go. I write down this equation. And your numbers are going to start getting bigger here. You got to be comfortable with that. Does it make sense for C to be 0? These start at the origin, right? So it does make sense for that to be 0. Let's hit graph now. Let's see what happens. There, I could tell that it crossed here. So I'm going to chase the curve. I'm going to go a little bit higher on my Y max. I'm going to go 1,000. It's pretty good. And now I'm going to chase it to the right, which means I have to change X max. I'm going to go 5, let's say. Because remember, this would be a price of 5 would be out here. And based on what we're charging already, I think we're going to stay within. Right? So do you see the 3 points that we found? Right? They're right here. That's why it looked like a straight line when I zoomed into that. But then I went X min negative, Y min negative, and then I graphed it and chased the curve. Okay. What ticket price would result in the maximum profit? So they want the ticket price and what the maximum profit would be. Okay. What is that maximum profit? That's found at the vertex, right? Find vertex. Always read carefully, of course. So we're going to go second, trace, max. Okay. Second, trace, max. You go to the left, to the right. There it is. 1.399. So that'd be 140. Okay. And the maximum profit for us is $784. Write down that coordinate first, and then let's answer. Okay. A ticket price of $1.40 will result in the maximum profit of $784. So it's kind of like a combo, but we need to know, we need to make sure you understand what those numbers represent. Okay. D says how many tickets are expected to be sold at the price in C. So at this price, how many tickets are you expecting to sell? I will remind you of this formula. Profit is right, price per ticket times tickets. That is a formula that you always want to go to when you're answering this type of question. We know that the profit is $784, correct? We know that the price, based on the previous question, is $1.40. And we know that tickets is unknown right now. Just basic algebra here. What will we do? Divide both sides by $1.40. Why am I using this formula? Because we don't have the number of tickets compared to the profit. We don't have that relationship. So I use this formula. So tickets, when you divide that, you get, is it exactly 560? It's exactly 560. If it hadn't been exact, then you just round it to the nearest whole number if it happens to be different. I'm not going to graph this one. I'm just going to answer this one and ask you to try one before we go. So you will have 20 minutes to do this. Let's just pay attention to this part. What ticket price or prices would give or yield? Have you ever heard of the word yield? Yield is the same thing would give us a profit of $450. Explain why there are two possible prices. Well, remember, every single point is price per ticket and profit. Right? We've established that if you look at your equation. And in this case, profit is $450. So we're wondering what price would give us a profit of $450. What would you use? What function would you use on your calculator to figure this out, to figure out the x value? Y2 is equal to 450. And then it's second, trace 5. So let's go ahead and do that. I let Y2 equal to 450. I hit graph. And what do we find out? That there's more than one instance that will give you a 450 profit. How so? Well, if you charge less, like the cheaper price, right? There's a point where you sell 450, but then you can charge more and still get 450. The reason is you will sell fewer here, but you're charging more per item. In this case, you will sell more, but you charge less per item. That's it. That's the reason for that. So I'll just have this here, have our curve. This is the 450 line here. So this is the first ticket price. This is the second ticket price. We're not going to subtract them because this is not a time question. So if you find the first, this one here is 231. And the first one is 0.49. Okay. So a price of either 49 cents or $2.31 will result in a profit of $450. Can you see that? So, at 49 cents, we sell more tickets. At 231, we sell fewer tickets. So it's up to you as the business to decide, what do I want to do? Do I rather charge less so that more people can benefit, or do I charge more but I have fewer customers coming to me but I still sell the same? Okay. So that's how it goes. All right. So what I would like you to work on, I've selected pages 56 to 57. Okay. And I'll post a key to that. I'll bring this page back in a bit. I just want to explain. Yeah. So your main task right now is to read, be able to fill in this table, come up with your quadratic, and answer some questions. I don't really want you to focus too much on graphing right now, because we'll do graphing with the other questions. Okay? I don't think I asked you to graph anyways. So we'll leave 55 blank in our notes. That's I do that on purpose because I don't really ask you to graph these types of questions. Because it's not really a requirement. Okay, so homework, again, 56 to 57. You want to be able to be comfortable with this. Okay, 56 to 57, there it is one more time. If you're still copying, finish copying.